So first of all, we shall discuss what is PN Junction Diode. PN Junction Diode. In what way PN Junction Diode is formed? That is we have to know. Here we can draw P-type semiconductor and N-type semiconductor. P-type semiconductor and N-type semiconductor. And this is what we can write. This is P-type semiconductor and this is N-type semiconductor, which are placed in contact. And we get PN junction diode. In P-type semiconductor, majority charge carriers are holes. Here we can denote majority charge carriers as holes. These are holes. Positive sign and encircle. Hole is an empty space of positive charge, and minority charge carriers are conduction electrons. And we can denote the junction, and this is the junction of PN junction diode. Interface or the junction of PN junction diode. And on either side of PN junction diode, there should be a particular region. And that region is called depletion region. That region is called depletion region. In this case, initially we had a hole, and this hole will diffuse into inside, and at that position we get what? An immobile negative ion, minus. So we can denote here minus or immobile negative ions. Similarly, majority charge carriers in N-site or N-type semiconductor are conduction electrons. These are the conduction electrons, and we can denote holes as minority charge carriers. Initially we had conduction electrons. At that point, conduction electrons will diffuse into P site. Conduction electrons will move to this site, and as a result of diffusion of this majority charge carriers, in this region immobile positive ion is formed. Immobile positive ion is formed. So in this way we get PN junction diode. An accumulation of immobile ions will set an electric field or potential difference, and this is a 50 source battery having EMF VB, which opposes the further diffusion of majority charge carriers. So this is a diagram of PN junction diode. This is a diagram of PN junction diode. And this layer, obviously this layer is known as depletion layer or depletion region. This layer is called depletion layer or depletion region. This region is called depletion layer. This is depletion layer. These are the two terminals of PN junction diode. In this case, we can denote this as holes, which are majority charge carriers, and this dot means what? Please respond. This dot is what? Holes.
Conduction electron.
Electron na?
Not only electron, it should be conduction electron. Conduction electron. In this case, this conduction.
আমি এই জায়গাটা একটু ডিসকানেক্ট হয়ে গেছিলাম, এই জায়গাটা একটু বলে দাও তোমাকে।
Disconnect spelling নাকি?
না, ডিসকানেক্ট স্পেলিং না,
No.
এই খানিকটা জায়গায় ডিসকানেক্ট হয়ে গেছিল।
আবার বলতেছি দাঁড়া, কি হবে ইংলিশ টিচার লিখি। Minority charge carriers. Conduction electron is the minority charge carriers, and holes are what? Majority charge carriers in this case. And this dot is again conduction electron. PN junction diode. In this case, depletion layer is formed in what way? Obviously, this depletion layer is formed, which is formed. Depletion layer is formed due to accumulation of, due to diffusion, not migration. It should be due to diffusion. Diffusion of what type of charge carriers? Majority charge carriers. Majority charge carriers across the junction from one side to another side. Across the junction from one side to opposite side. Across the junction from P side to inside or inside to P side. From one region to another region. From one region means either P side or P inside to another region. One region, P or N side, in region, to another region. And what about VB? VB is a potential difference. Potential difference which is set up due to accumulation of immobile ions. Potential barrier. This is known as potential barrier acting across the junction of PN junction diode. And this are what? This negative sign. This negative sign is immobile negative ions. This is which cannot move. Immobile negative ion which is obtained due to diffusion of holes from P side to inside. Immobile ion which is obtained in what way? Which is obtained due to diffusion of holes from what region to what region? From P region to N region. So if we erase this negative immobile ions before formation of these immobile ions and before formation of immobile positive ions, initially we had positive holes. These are holes. and these holes diffuse in from p side to n side, diffuse from p side to n side. Why does hole diffuse from p side to n side? Because due to difference in number density of holes from p side to n side. Number of holes in p side is greater than the number of holes in n side. That's why holes diffuse from p region to n region. And what will be the final diagram? If holes diffuse from p region to n region, at this position hole has positive charge, so if hole leaves this position, leaves this position, here we should have negative ions. Clear or not? In what way immobile negative ions are formed or are obtained in depletion layer? Obviously, when holes diffuse from p side to n side. Similarly, in n side we should have immobile positive ions. Immobile positive ions. This is what immobile negative ion, positive ion. Immobile positive ion, which is obtained in what way? Please explain. Anyone? In what way immobile positive ion is obtained or is formed in depletion layer? Response kar digiye, which is obtained due to diffusion of what? Diffusion of
conduction electron.
Very good.
Conduction electron.
Conduction electron, not valence electrons, because valence electrons are bound to the influence of silicon or impurity nucleus due to covalent bond. And depletion layer, what is the function of potential barrier? Under bracket of potential barrier, what is the function which opposes? Potential barrier means which opposes further diffusion of what? Further diffusion of what? Holes or conduction electrons from p side to n side or n side to p side. That is further diffusion of majority charge carriers. Diffusion of majority charge carriers. Majority charge carriers. That means VB is the potential difference which opposes further diffusion of majority charge carriers. That means once potential barrier VB starts to act, in that case diffusion of more majority charge carriers is stopped. So this is the diagram of PN junction diode, and memorize what should be the approximate value of potential barrier acting across the junction. Potential barrier VB has the value 0.7 volt for silicon, 0.7 volt for silicon. Silicon is an example of semiconductor having atomic number 14, and 0.3 volt for germanium, which is another example of intrinsic semiconductor having atomic number 32. Don't mix up with the value of forbidden energy gap. Eg was the forbidden energy gap which has the value 1.1 electron volt for silicon. And what is the value of forbidden energy gap for germanium? Anyone? Response? 0.72 electron volt, and Eg is the forbidden energy gap. in that gap no charge carriers can exist. Forbidden energy gap exists between conduction band and valence band. This is forbidden energy gap. And what is the thickness of depletion layer? What is the thickness of depletion layer? That will be of the order of 1 micrometer. Width of depletion layer, width of depletion layer, width of depletion layer, which is equal to 1 micrometer, or of the order of 1 micrometer, not only equal, of the order of 1 micrometer, that is of the order of 10 to the power minus 6 meter, minus 6 meter. If an electric field acts, if an electric field acts, and that electric field acts from n side to p side, from positive plate of the fictitious battery, and this electric field is E. And what should be the value of electric field acting across the junction? That will be potential barrier VB by thickness is what? Width of depletion layer as D. VB is for silicon, it is not 1.1, কত জানো? 0.3 না 0.7 volt?
0.7.
0.7 volt divided by 10 to the power minus 6. So what should be the value of electric field intensity acting across the junction? That will be 7 into 10 to the power 5 Newton per coulomb or volt per meter. That is the electric field acting from n side to p side, and which oppose the further diffusion of majority charge carriers.